A uniform meter rule rests horizontally on a knife edge at the 60 centimeter mark, or we can say 0.6 meters, when a mass of 10 gram is suspended from one end. A. At which end must this mass be suspended? B. What is the mass of the rule? So we have to calculate what is the mass of the rule and also which end our 10 gram mass should be suspended. Now see, it was this situation before, like 50 centimeter from here we can say, and 50 centimeter from here. It was balanced, right? So its COG was here. Center of gravity of the scale was here. The whole weight was acting downwards. And because the weight was acting downwards and knife was supporting that, it was in balance. But now what we did, we shifted the knife this side. Now instead of 50 centimeter or 0.5 meter, we increased its length by 10 centimeter, or we made it 0.6 meter. Now what will happen? Most of the scale now will go this side and lesser side will be this side. So now the COG will be here. COG will not move according to the knife. It will be according to the scale, the distribution of mass. So our COG will be here, right? And knife is now 10 centimeter far or 0.1 meter far from this, from the knife. Now, which end we should put this 10 gram to balance it? Because they are saying that we have to put 10 gram suspended from one end. There is no point of putting it in between something. So what will happen is, if we keep it like this, because COG of the scale is this side, ruler is this side, it will try to rotate this side. It will swing it like this, or a anti-clockwise movement will be generated by it. For that, we need to cancel this effect. We will hang it at this end. Now what will happen? Due to this mass, 10 gram mass, a clockwise movement will be generated, and then it can be balanced to the force or weight of the scales anti-clockwise movement. So pictorially we can see it now. It's like that simplification. I have just shown dotted lines and I'm just shown the COG here of the scale. So this point is the center of gravity now, where we can assume that whole scale's weight is acting here. So the weight is acting downwards here, W. It will be 0.1 meter. This is the pivot or the knife point. This is the pivot. And now we have to find like which distance we should place this 10 gram. So the 10 gram mass, this was 10 gram. So the 10 gram mass will put a gravitational force of 10 gram force vertically downwards. Now, as meter rule is in rest or in equilibrium, its movement about its pivot must be balanced. One side will be the weight of the ruler and other side it will be the 10 gram. The pivot must be balanced using the principle of moments. We can say anti-clockwise moments will be equal to clockwise moments. So anti-clockwise moment is given by this, like it will try to swing it like this in anti-clockwise direction. So W is the weight of that ruler into 0.1, because the distance we have to take is from the pivot, and the pivot point is the knife where we have kept the knife. And now it will be equal to the clockwise movement, which will be created by this force, 10 gram force, multiplied by 0.4. Because now if it is 60 centimeter or 60 centimeter till here, what will be the left? Because the meter was of 100 centimeter, so the length will be 40 centimeter this side, because it was 100 centimeter, the 40 centimeter will be this side and 60 centimeter will be this side. So we can equate this and finally we can find it. The answer will be 40 gram force. So the 40-gram force will come due to what mass? The mass of the scale will be 40 gram, of course. So 40 gram will create the force downwards of 40 gram force. So if we get this, we automatically have got the mass of the ruler, which will be 40 gram. Now, next question. There is a seesaw. Two children have different masses, 30 kg and 50 kg, are sitting on one side of it at distances 2 meter and 2.5 meter, respectively from its middle. Okay, so they are both sitting on one side. So this is what they have mentioned. It's on one side. Where should a man of 74 kg sit to balance? So this is a simple question of principle of movements. So they are sitting like this. So what I have shown here is the 30 kg mass will exert a force of gravity will be vertically downwards of 30 kg kilogram force. 50 kg will be 50 kilogram force. Now what will happen? We have to make a person sit here. At what distance it should sit, because the mass is given 74 kg, so that he needs to balance. So first what we are doing is, first step we are, let's calculate like how much in totality these two children are generating the clockwise movement. So this I have calculated it first. 30 kilogram into 2 meter respective to the distances from the pivot. So we can get it 185 kilogram force meter. Now let's see the next step. Now the 74 kg mass person should sit on the other side. Then only he can create the anti-clockwise movement to balance these both guys who are giving this resultant movement. So this, his force will be 74 kgf, but we don't know the distance. That's what they are asking, like how much distance he should be sitting. So we will, so the man has to create anti-clockwise movement of the same magnitude. So we can apply the principle of movements. Then clockwise movements and anti-clockwise movements should be equal. So 74 kilogram force into D will be equal to 185 kilogram force a meter. So now you see the kilogram force and kilogram force. We'll cancel out these units and we will get the answer D is equal to 185 divided by 74. And the answer, if you divide it, you will get of 2.5 meter. So this is how we can solve this question. So that person has to be at 25 meter from the pivot if we want to cancel or balance both of these children. Now here below shows a uniform rule AB pivoted at its end A at the zero mark. So this is a zero mark and supported at the other end by a spring balance. Spring balance, what it is doing, it is supporting it. So it's not letting it go down. When a weight of 40 kilogram force is suspended at its 40 centimeter mark. See, this is the 40 centimeter or zero point 0.4 meter. It is here, this mass. So the force will be downwards of 40 kgf. It should be downwards. We should show force downward like this. So the force will be like this, suspended at the 40 centimeter mark. This rule stays horizontal. What does that mean? It is in the balance. So the movements are getting cancelled. Find the reading of the spring balance. Reading means how much force this spring will be applying. Number one, when the rule is of negligible weight. When the rule, second is when the rule is of 20 kilogram force. When it has some mass, when it doesn't have any mass. So in both condition, we need to solve it. So first let's consider like when it doesn't have any mass. So what mass we are having, we have to consider only this mass and the force will be balanced by this. So if it wants to turn it like this, it wants to give it a clockwise movement. So this spring has to provide upward force to create the anti-clockwise movement, and that's how it will balance, and that's how what will be the reading we'll get to know. So we will apply the principle of movements in this case when there is no mass of this scale. Let's do that. So first, no weight of ruler. means we do not need to think about its movement. Its weight will is negligible. Now we will apply clockwise movement of weight. Clockwise movement. This will create like this. See, the pivot is this. Remember that. So this will create a clockwise movement. That will be 40 kgf into zero point 0.4 distance from the pivot. Anti-clockwise movement will be F. We don't know. This force we don't know. Let's say its spring gives the reading of F, or it exerts force F, then it will be distance of 1 meter. Why I have taken the 1 meter? Because distance will be always from the pivot. So it will be 1 meter. It is a meter scale. Remember that. So that's why it is 1. Now we need to apply principle of moments. These both moments will be equal and we will get the force as 60 kilogram force. So this is the answer when the ruler is of negligible weight. Now, what if it has some weight? What if this ruler also have some mass? What will happen to the reading? It will increase. Why? Because now there are two masses which will be hanging downwards. One is this, already giving this much of movement, and other mass will be which we can consider at the center of this scale, which is acting downwards. This spring now has to support that also. So that's why it will increase. Let's see how much it is. So now when the ruler has weight of 20 kgf, this will also create the clockwise movement, right? It will, like the other mass is doing, it will also start creating clockwise movement. We can think of it acting at the midpoint or its center of gravity, which will be in the middle or zero point 0.5 meter. So this will be the clockwise movements. One is 40 by the 40 kgf force downwards, and other is the ruler's mass. Now this 20 kg force is due to that mass multiplied by zero point 0.5, because we are thinking about the center of gravity, which is be acting at the midpoint of the scale. So these movements will be equal to the force by the spring into 1 meter, because the spring has not changed its distance. It will remain there, so F into 1 meter. And now this will come as 16 kgf, plus this will come as 10 kgf meter, meter, and this will meter, and this will cancel out. That's why I not shown it. And now we can get the F will be equal to 26 kgf. So now the reading has increased. Previously it was 16, but now because there is a mass of scale also, it has increased by 10. So the force reading by the spring will be of 26.